Developing and manufacturing electric vehicle systems. Why electric cars? Road transport accounts for a significant air pollution in urban areas. Why choke with our own emission? To overcome this massive exhaust emissions, we have to do hybrid or full electric vehicles, which also skips very complex and difficult IC engine development. An electric vehicle requires less mechanical complexity and rely more on electronic prowess. A Chevrolet Bolt's electric propulsion contains just 24 moving segments. According to the teardown performed by consulting company UBS, in comparison, a Volkswagen Golf's combustion engine has 149 segments. Actually, if you look at parts, it will be 2,500 parts. Any product development is a various process with the help of virtual and hardware assessment of product characteristics to ensure fit, form, and performance of parts or subsystem of vehicle, resulting in a good product. Tools to develop products, validation, and production are essential items for producing great products. Our proposal is to have four-phase approach for a thriving electric vehicle industry. Number one, CAE Center, Automotive Research and Assessment Center, Arac, Battery and Electric Drive System Center, Dhaka Automotive Assembly. Now, with the short description of these centers, since the early days of automotive industry, one means of product manufacturing, quality improvements, and cost reduction have come about by studying, comparing, and analyzing competitive newest products. Hence, Arac, the Automotive Research and Assessment Center, built benchmarking and total cost management center, which will be used for common research and assessment for current automotive OEMs like GM, Ford, Toyota, and others. These centers will provide service to OEMs as well as suppliers. Arac will be the hub of developing and training engineers with vehicle design, development, manufacturing processes to support domestic market with mobility solutions and also be part of global automotive industry. Arac will work hand in hand with the CAE Center to become the knowledge center for battery and electric drive systems and support for DAC. Here is a pictorial of the two, like a chassis, rolling chassis, and also a whole vehicle system that can be displayed and tore down and displayed, and reports will be issued. Battery and electric drive system center. Electric drive system components are rechargeable energy storage systems, battery pack, power inverter module, electric motor, motor controller, ISG, ultra cap. NRB engineers can contribute significantly to develop an electrification center and train our Bangladeshi engineers and technicians to produce electrified drive systems. Now, the battery packs there's three types of battery packs. Lithium ion, the predominant choice, especially for electric vehicle, high power density and moderate energy density, and used by most OEMs for electric vehicle. Nickel metal hybrid, high energy density and moderate power density, used mostly by Toyota for their power split hybrid system. Lead acid, which is the medium power density but low energy and density for short range. This battery is actually being produced in Bangladesh also now, which can be used for low range vehicles. And here's a pictorial of the inverter, the battery system, and how the whole electric system works with the main vehicle. Electric motor. Electric motor provides the propulsion force for electric vehicle. Several types of motors are currently used for electric vehicle: permanent magnet motor, induction motor, and wound-field motor. Permanent magnet motor, mostly used by OEMs and suppliers like GM, Toyota, and Nissan. Electric motors can be manufactured in Bangladesh, but it will need some training, and Bangladesh has the basic expertise. Power inverter module, PIMS, converts direct current DC voltage of the battery pack to alternate current AC voltage to drive the electric motor. This is very similar to the UPS systems that we have in Bangladesh. PIM used in vehicle is much more power dense and is much of higher power levels. Again, Bangladesh has the basic expertise to develop PIMs. Here we have some pictures of the motors, the permanent magnet motor that General Motors uses for its hybrid vehicles, and the power inverter module of a Cadillac CT6 plug-in hybrid vehicle. Motor control. Motor control is a massive thing in doing the electric vehicle. As you can see, there's a battery pack, the power inverter module, the electric motor, and the controls diagram. The controls optimize for efficiency and performance, balancing noise and system cost. Motor control algorithm is programmed into microcontroller. Motor controller drives the inverter that controls the motor. This expertise again it needs to be developed for Bangladesh. The curriculums in Bangladeshi universities are very strong in power, but we need to train our engineers for the requirement of the workforce that will actually work in this motor control area. Expected outcome. No country can ignore the auto sector, which is globally worth 2.4 trillion. Time has come for Bangladesh to get a piece of the pie. NRB engineers can play a very significant and crucial role in making Bangladesh an electric vehicle manufacturer by establishing these institutions and working in collaboration with academia. Detroit NRB has the full expertise and capability to make this happen. Impact on Bangladesh. CE Center, Arac, EV and battery centers, and DAC will develop our engineers to be in the forefront of advanced automotive engineering and manufacturing. DAC is like Dhaka Assembly Center, which will be like a partial knockdown plant, which will be the vehicle assembly center, which was part of this whole plan. China and India are rapidly becoming the biggest player in global automotive sector. While China is poised to become the leader in electric vehicle manufacturing, India is projecting a 300 billion auto industry. It is going to be only natural commerce for these countries to get engineering and manufacturing services from Bangladesh. Needed resources, facilities. For Arac, we are planning for 3 different locations, Dhaka being the number 1, then Detroit, and eventually Torrance, California, because of the vicinity of the industries and the hubs of global vehicles, automotive sectors. We need common areas for cutaways, teardowns, and benchmarking and comparison boards, engineering and development and training center for talent development, battery lab, dyno and calibration labs, and classroom type setups for facilities for training classes, flexible management for privacy and security needs, and the facility for DAC, the assembly plant, which will be a further future project, will require a lot of space, as you can see here, like 4.5 million square feet of manufacturing space. But all of this needs to be studied some more. The business plan, budget to develop detailed action plans and feasibility studies for Arac and battery EV center is 4.5 million. Now, these are all preliminary numbers. As I said, we need to do a deep dive into these numbers and come up with more realistic numbers. Arac and battery center can generate cash flow within a very short period of time and eventually start positive cash flow. DAC will generate cash flow immediately after commissioning with the project and possibility of earning foreign currency also. So this sensor will be self-sustaining after a couple of years. And if we have to do a pilot project, we need a seed money of approximately 3 million. And here's a breakdown. The Arac center is 1 million and CAE center for 500,000. The battery and electrification center is 3 million. And eventually when you do Detroit and Torrance centers, we'll need 5 million. And DAC will have to be studied further for the actual numbers and to come up with a realistic plan for the assembly of an actual vehicle. So with that, I conclude like our proposal is all-encompassing. The Arac, the assessment center, will be the umbrella organization that has the CAE center, the battery center, and eventually a manufacturing plant. Thank you for listening to me.